Hi there, this is Paul Edwards with Danmark Company. You're able to get a hold of myself or ask any further questions that you might have regarding the continuing education that we're going to have right now. You can forward your questions to Paul Edwards at Danmark Company. My email address is danmarco1@msn.com. Or you can call me directly at 817-822-5767. This is a continuing education on the Danmark dip system, and we're going to go over some neat features of this system. We are constantly looking to make improvements, and so those improvements are passed on to our customers, and then we try to explain the ideas that we have with our improvements. First thing I want to discuss is the safety. Anytime you're going to use hazardous chemicals, you need to wear your gloves. You have to wear gloves, and then you have to wear safety glasses to protect your eyes and your hands and your skin from that, okay? So you got safety glasses, you've got rubber gloves. Like we handle the safety glasses, and we handle the nitrile gloves. So this right here is a 6 mil nitrile glove that comes in, and I have an 8 mil also nitrile glove that comes in blue or black. Okay. So anyway, some of the nice neat features that we have, you recall the floating valve. This valve right here will trigger on and off replenishment of these tanks with your antimicrobial agent. So when it's in this position here, it goes on and controls your valve to shut it off. If it's on the down position like that, it will go on and trigger replenishment. And the greater that knob is in the down position, that's the longer that will be your longer time for replenishment. The quicker that you leave this down and then allow it to come back up, the sooner that you allow this to happen, then you have less replenishment rate, okay? And today we're going to be measuring that replenishment rate. Did you notice that this is a see-through tube on our floater? One of the reasons why I introduced a see-through tube is you'll have an ability to look inside your tube for a period of time, okay? The materials, corrosive materials that most of these antimicrobial agents are, is going to degrade the outside covering of this tube. So there's going to be a point where you can't see through it. And all you have to do is replace it. Danmark Company sells these, and we'll be glad to replace that, and so you can keep it where you can look through it. The other tubing that we replaced and made it clear also is your lower. This is where you're replenishing at. So basically, this floating valve, this float is controlling this valve here on the bottom. I don't know if you can see that. I'm gonna check my camera. Yes, you can. So this is a valve right here that opens and closes, and it triggers that. And this is clear also, so that you can actually see the chemistry moving through it. And then I've also incorporated a check valve. I have a 90 degree here that's connected to it, and I've got tubing, and that's for our continuing education. What we're going to do is we're going to take a look at what is the replenishment rate in a 1 gallon per minute, or what it is in gallons per minute. Okay, so what I'm going to do is I'm going to fill this container up. It's a graduated container. It's got measurement there, and I'm going to do it for a period of time, because I can't. If I'm flowing at 5 gallons per minute, of course I can't run it for 5 gallons for 5 minutes, because, or if this flow rate is 5 gallons per minute, I probably can't run it for over a minute or even up to a minute, because I don't have 5 gallons here, okay? So what we'll do is we'll just run a timer, we'll run the flow to it, and then we'll shut off the timer when this fills up, and then we'll do our calculations to see what our gallon per minute flow rate is on that. Okay, so the reason why we have the check valve is it acts as a backflow preventer and keeps the chemistry or whatever might be in this tank that maybe originate from meat, or originates from produce, or originates from poultry, or it originates from seafood. You know, this equipment is used in several different markets, and so that's basically, we don't want that replenishing, or we don't want that going upstream. Okay, we want a check valve to keep that flow going one directional. And when you clean it, you can disassemble all that. That's a nice little feature. But anyway, we're back. We have these tanks, and tanks are designed to hold the antimicrobial agent. And then every time we trigger this with a box container that has the produce in it, or the poultry in it, or the chicken, whatever, or I mean beef, pork, whatever this is that triggers this valve to on and off, that's what happens. Now, you notice how I can set that angle up? Okay, the determining factor of that angle, and of course, if you've seen the first video, you already know all of this, but I'm just going to go on and just go over it briefly. We have these dip boxes, okay? These boxes are designed to dip in here. Okay, see, I have it too high. See, this is way too high for this valve, so what I have to do is make an adjustment. Now, what the whole idea is, if this turns off your flow rate, and then here I mean, if this opens your flow rate because it's an up position like that, and then this turns down your flow rate, then you want to be able to use this box effectively to control that. So this is too high. So what I have to do is, in order to adjust that, I have to there's a little screw here, open this up, and then lower it to a position where my box fits in this container and triggers it. So I'm gonna, now you see how I'm able to submerge this? Okay, so we got a submerge. We got it submerged. So that is what we want. We want this to submerge, and then we want it to float to the top to turn it off. So if I take off my box, it's going to replenish up to when it stops flowing, okay? And then when I put my new box in there, bam, it's going to push it down. So you got chemical going in, fresh chemical, and then you got, bam, you got chemical filling up the tank and from the bottom, and then it triggers that to close. So that's basically how it works. Now, you all are probably, if you've seen the first video, you're probably wondering, hey, is there something missing? There's something that I don't see, and I saw it before. Where is it? You know, for you observant individuals that are noticing, off of this, it will be a 90 that will be a tubing that is about the size of this, at about the level right here. So it's going to be an overflow that's going to be at this level here, okay? And it is missing the overflow drain. The overflow drain is not put in here yet because I'm doing a continuing education on replenishment, but it will be there afterwards. And as you recall, the overflow drain that sits up about this high, it goes directly into the drain. Okay, it doesn't go on the floor where people are going to slosh around in the solution. That is something that has to go directly in the drain, and we'll go over that a little bit later. But right now, what I want to do is I want to go and I want to measure the replenishment rate. So the first thing you need to do is you need to put your tubing in your capturing device. So whatever's going to capture the chemistry, you want to put it in there. And then what you want to do is you want to have a, well, we'll make that happen here in a second. Then you want to have a timer that's going to measure that flow rate. Okay, so I'm going to have a timer, and basically what I'm going to do is I'm just going to look at my timer, and the moment that the flow has exceeded the capacity of my measuring device, I will hit my timer, and that will turn it off, and then I'll know exactly what that flow rate calculation is going to be. Okay, so I've got my stopwatch ready. I'm gonna have my tubing ready here, but first what I gotta do is I gotta turn on my water. So this is all gonna be pretty neat stuff here, figuring this out, making it work. But I have confidence in my ability to make this work. So okay, so I'm gonna make this flow. I'm gonna make this, and listen in the background, please. You're gonna hear that mini dose pump in action, allowing the flow to start. So here we go. I'm gonna turn it on. Okay, the water's on. You hear it running. I'm gonna hit my timer. I'm gonna hit my timer here. Here's my timer. I'm gonna start my timer. My timer is running. Now I'm gonna fill this up, and the moment it fills to 20 ounces, I'm gonna turn this off. Bam. Okay, so there we are. We're done. Was that quick or what? So that pretty much filled that up pretty good. And so basically, what we have found out here is that in 12 seconds, we were able to fill our 20 ounces of, what is that, 28 ounces. So we're able to fill a 28 ounce container in 12 seconds, okay? So you mathematicians out there, maybe a little more. Okay, well, let's do this. Okay, let me go on and say that we were able to fill 30 ounces. What this claims to be at the very top. At the very top, we're 1 quart. So it is considered 1 quart at this line right here. Okay. So right around in here is 1 quart. So I would say approximately we have a flow rate of 32 ounces in 12 minutes. Okay. So if any of you guys are mathematicians, you guys can figure that out, what the gallons per minute is and what it's not. I'm going to come up with that number later on for you. But here's a couple of interesting points I want to make. Okay. Now that we got an idea what that flow rate is, and I'm going to let this run a little bit longer, but now what I'm going to do is I'm going to go on and introduce to this whole idea here that we're working with. I'm going to introduce, and of course this tubing here would not stay on, so I guess I could take it off. It's not a big deal. Okay, here we go. Let's take this tubing off. It's gonna come off. There you are. Bam! Okay, so now what I'm gonna do is I'm gonna run this system, and I'm gonna go on, give you an idea what you can expect from your dip system, your mechanism, your clear float here, and your solution. So it's filling up right now, and I want you to see something here. Let's say that the level had increased. See how that turns it off? Okay, I'm going to trigger this other one. We've actually got 2 tanks, so that's a double dip system where you can dip into one system and then into the other one. So you got your valves, both of them are up. It's turned off your water, okay? And then all of a sudden, you put your box in here. You dip your box in here, so it replenishes, and then bam, you're up and it's turned off again. Okay, so you're down, and then you're up. Down, and you're up. Now the reason why you're seeing that pressure come out pretty fast like that is because the other dip tank is not triggering on or off. So it's just this one here. Now if I do both of them, see how that reduces the flow? So that's another consideration, is that that your flow is affected by both dip tanks being replenished. So this flow rate right here might vary a little bit, and that's the reason why I did it based on two systems. Okay. Okay. Yeah, these replenishment rates are approximate because everything changes with overall water pressure. So if you have water pressure being driven by potable water supply to your plant, that's going to affect your flow rate. If you have water pressure affected by pressure reducing valve that you've put in to your line, let's say that your plant water pressure is 80 psi and you want to reduce that down to 30 psi or 25 psi or 15 psi, you do that with the pressure regulator. So basically what you do is you go on and reduce it there, and then let's say for example that your pressure can also be affected by one tank being on and one tank not being on, or one tank being opened and one tank not being open. There are a lot of variables in plant water pressure, but what I just showed you today is how you can get an idea using a measuring container and this valve here, tubing that is placed directly in a timer that is measuring how many seconds pass to fill up that container. And as you recall, we had 12 seconds to fill up 32 ounces of a container. So that's a pretty significant flow rate, even with both tanks filling up at the same time. So that's a pretty significant flow rate, okay? And every time you depress that unit down, it's going to have a specific flow rate based on the valve being down and the valve being open and the valve being closed, okay? So we'll come up with those math answers later on what all those totals are. I don't want to figure them out in my brain right now, but we'll be moving to our next continuing education on this in just a second. Hello, Paul. Hello, folks. I'm back. This is Paul Edwards with Denmark Company, and cleaned out some of the water. I did my mathematics with the figures that I was looking at. Now I'm going to go on and retest. This time what I've done is I've made some technical changes to our system. You may recall that when we did the last timer test, we found that we had filled up the 32 ounce container in 12 seconds, okay? So if you do the math, okay, and here's how I came up with my answer. So if you guys want to take your calculators out and check me out, you're welcome to do that. Basically what I did is I took 12 seconds, okay, which is how much it took to fill up the 32 ounces. I took 60 seconds in a minute, and I divided it by 12, so that left me 5. Okay, so that means that there are 5 12-second intervals in a minute, okay, of 30 seconds, okay? I took that 12-second interval that I figured out that there was 5 of those 12-second intervals, and I took that 5 and I multiplied it by 32 ounces because that's how much that container filled up to. And that turned out to be 160, okay? And so that's a lot of flow there. I'm kind of really pleasantly surprised about that fact. Now what I'm going to do is I'm going to go on and redo the test, but this time what I did was I installed in my water supply a 25 psi regulator. So now what you'll do is you'll see what the flow rate is with the 25 psi regulator, same valve opening position, so the valve opening, but now I have a pressure regulator in place. So you should hear a difference in your pump because your volume is going to be changing. So as soon as your volume changes, your pump sound changes as well. Kind of interesting dynamic there. And then what we're going to do is we're going to go on and test and see what the capacity to fill is. Okay, so what I'm going to do is I'm going to go and start this, and then you watch me there. Okay, I'm going to get my water ready. I'm going to get my timer ready, and I'm pretty close here. So I got my timer going. I'm filling up here. And as soon as it gets to 32, I'm going to turn this off, okay? And these are give and take a couple of seconds, folks. So that's just the way it is. Okay, here we are. We just filled it up. So here's what I'm finding out, okay? We might have saved 2 seconds, okay? 2 seconds. So, for you really smart people out there, and you say, well, 2 seconds, you know, you say, well, how many gallons is that? Well, if you were flowing at, well, I'm going to keep doing math here, and I'm trying to figure out, okay, if I found that flow rate was not acceptable, how would I change that, okay? In 12 seconds, I put in a 25 ppm or 25 psi regulator, so it took you down to 25. I'm still I saved myself 2 seconds to fill that up, so or extended is the word I'm looking for. Instead of it filling up in 12 seconds, it filled up in 14 seconds. So by putting in that flow regulator, I did slow down the flow, or pressure regulator, I did slow down the flow. But what if that wasn't acceptable? Well, then you'd have to go and look for a PSI reducing valve, or you could go on and have a flow regulator valve. I'm actually doing everything with a pressure regulator, but you could actually have a flow regulator where you can control the flow there. Is it because you're thinking that you have too high a flow? And if that was your concern, I mean, based on what? Okay, first of all, let's think about this for a second. Okay, this valve here is what's controlling the flow. It's not going to flow that flow rate continuously, okay? Why? Because that valve is going to prevent you from letting you flow that flow rate continuously. This tank's going to fill up, and this valve is going to be the modulator that's going to modulate or control or make the flow rate variable. And it's not, every time you press that basket and you push it down, if you hold it down for only 2 seconds, that's not too bad, okay? And you have to have that type of replenishment to kind of pacify your concern with community bath, because one of the biggest problems in the industry is and the reason why I say it's a problem is because there really is not a lot of information regarding community bath. A lot of people are using community bath, but to know whether you've got a challenge with community bath or not, that's a very vague area, so I don't really want to try to touch it. There's a lot of variables you have to look at. But with that concern of community bath out there, okay, whether it's specified or not specified, this right here at a replenish rate of 2 seconds of, so I just wanted to give you those facts, and I want you to know how important the dynamics are that you're working with. And a lot of times when you and I have a kind of conversation, we're going to be talking about this. I'm going to say, have you validated your flow rate? Did you run the tube into this, and did you fill up a container? You know, did you validate your flow rate? That's what validation is all about, folks. It's knowing how much is coming in, having a general idea of how long this valve depresses. All of that's part of your validation understanding. Validation doesn't mean that you have to report something. A lot of times what validation means is just that you have your own general understanding in the plant as to what your parameters are, what your factors are. Those are very important. I want to thank you for this opportunity to talk to you about the dip system and continuing education regarding the dip system. And if you have any questions, once again, just email me, call me up, whatever. Be happy to help you. I want to also plug the fact that we are doing validation services. Those are available for your plant. We'll come out, we'll take a technical look at your situation. We'll create an understanding of your parameters. We'll look at replenishment rates. We'll look at flow rates. We'll look at all of this. We'll teach your people how to do these repeat validations, and we'll talk about it. We'll do dye tests at your facility, all at a very small nominal consulting fee price, or technical fee price for you guys, so that we all, as part of our technical services, we'll do that for you. And it doesn't matter whose antimicrobial agent you're buying, whether it's ours or somebody else. We'll teach your people how to do these validation studies, irregardless of whose chemistry you're using. I think this is a very important point. I think that you need to have somebody like myself who's done this frequently to help you there. And but that's enough of my pitch. As you know, we do handle antimicrobial agents. We handle acidified sodium chloride. We have several organic acid lines. So, keep us in mind. We're out there to help if we can. We also handle our new calcium hypochlorite system too. We have a calcium hypochlorite line that we have. So thank you for your time, and thank you for your business. Thank you for your interest. Hello, this is Paul Edwards with Danmark Company. We've got a test here that we're going to perform, but before I go into the test that I'm going to perform here for a customer, what I want to do is I want to go on and share with you some facts regarding the question regarding the flow rate earlier on this study, and what we're doing basically is we're looking at the flow rate of refilling replenishment, and I realized that I might have been wrong when I was giving you some numbers. When you have a flow rate of 12 seconds that fill up a 32-ounce container in 12 seconds, okay, well, what you're basically doing is you're taking 60 and you're dividing it by 12. That gives you 5, right? And then you take that 5 and then you multiply it by the 32 ounces, right? It gives you 160 ounces, and that is 160 ounces per minute. And then you have to take that 160 ounces and divide it by 128, and that puts you about 1.5 gallons a minute. So we're flowing at a flow rate of 1.5 gallons per minute on our replenishment. Okay, so I just wanted to make sure I covered that. Now what I do is I got fajitas here. I've got fajitas that have not been treated. They have not been sprayed at all. I've got this ones on this side, as you can tell, that's color there. And then I've got this one right here on this side. So basically I've got the non-treated, and then we've got the non-treated. What I'm going to do is I'm going to go on and take this side right here, and I'm going to dip every piece into this tank. Okay, so I wanted to show you that. Okay, and then now what I want to do is I want to move towards the tank so we can make sure that we get the tank there. So we've got the meat here once again, and then we've got this is going to be the untreated, this is going to be treated. So I'm going to take the first one and I'm going to dip it in here, totally submerge it. For this one here was for about 2 seconds. Okay, this one's here for about 2 seconds. I'm going to stick it in the bottom. Then I'm going to take this one here and I'm going to submerge it. I'm going to submerge it for 4 seconds. 1, 2, 3, 4. So this is the one that is for 4 seconds. Then I'm going to take this piece of fajita meat and I'm going to submerge it for 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then there's that one. Okay, now what I'm going to do now is we've got these pieces that are treated, and when I want to compare them, this one's the one that was for 10 seconds. This one right here is the one that was for 4 seconds, and then this one right here is the one for 2 seconds. And I'm going to show you, these are the ones that are not treated. Okay, that one's not treated, that one's not treated, that's not treated. So basically what you're seeing is the comparison of the treated versus non-treated. And you get a little slight, not a lot, but you get a little slight change in color, but not anything to really speak of that would be a problem for organoleptic purposes. Okay, so what we're looking at is we're looking at about 10 parts per million free chlorine dioxide, and we're looking at 180 parts per million total acidified sodium chloride. So this is your non-treated here on this side. This is your treated on this side. Fajita meat. That's all I wanted to demonstrate there, folks. If you have any questions, forward your emails to Paul Edwards at danmarco1.net. That's danmarco.net. co1.net. Sorry about that. And I'm going to give you a close-up view of the fajita meat, the treated and non-treated, just in case anybody wanted to see the close-up on that. And by the way, I plan on eating these a little bit later, so if you're in the Fort Worth area, you're welcome to come out and enjoy some fajita meat with me. This right here is the untreated, right there. That's the untreated. This is the treated. Okay, folks. We appreciate the opportunity to service you. If you have any questions, feel free to give me a call. Left side untreated, right side treated. We appreciate your business. We appreciate any questions you might have. I want you once again to take a look at the chemistry. That is what 10 parts per million free chlorine dioxide, concentration of 120 parts per million total acidified sodium chloride. And just for the heck of it, so that you guys can see what the pH is, take my pH strip, put it on there. You can see that we're very close, between 5.5 and 6 pH. So we really appreciate the opportunity to help provide these technical information. And don't forget that 160 ounces per minute has got to be divided by 128 ounces to determine gallons per minute. Thank you very much. Have a great day.